Here at RadiciGroup, sustainability is right at home. All the activities of the RadiciGroup specialty chemicals, high-performance polymers and advanced textile solution business areas are carried on with full respect for the environment, people and communities. The group has a worldwide presence with 3,000 employees and more than 30 production and sales sites that produce materials for numerous markets, including automotive, electrical, electronics and textiles. Every single day, we work hard to make the circular economy our business model. By optimizing processes, reusing scraps, and promoting recycling, and we always measure our performance. Through our annual sustainability report, we publish on our economic, environmental, and social performance in a transparent and objective way. In the last 10 years, we have reduced energy use by 17.5%, CO2 emissions by 61.5%, and water use by 8.6%. And we're not going to stop here. We will continue to team up and optimize supply chain synergies for a circular and sustainable future. And that's why we are part of the European Car EService project.
The RadiciGroup project has received funding from the European Union's Horizon 2020 program. The goal of our project is to develop innovative circular economy business models for the automotive industry. In particular, we have focused on reuse, recycling and regeneration of some key components coming from end-of-life vehicles. RadiciGroup high-performance polymers is the only producer of engineering polymers participating in the RadiciGroup project, which is coordinated by the National Research Council of Italy. We have performed quantitative feasibility studies on polyamide recovered from automotive components. The parts have been dismantled from the end-of-life cars, properly treated and then recompounded. The aim of the project is to produce engineering polymers using secondary raw material obtained from the end-of-life parts and to obtain the performance comparable to that of engineering polymers made with virgin raw materials. Potential uses include high value-added engineering application with high end-of-life recyclability. In the RadiciGroup project, we have focused on the recycling of polyamides component, validating the procedure also for other thermoplastic polymers.
The first step was to identify the components to be tested for recovery. We had to find the right compromise between polymer quality, dismantling ease, cleanliness, and the need for metal parts separation. Our choice fell on airbags and wheel covers, both of which are made from polyamide. To validate the process and determine if it could be used for other thermoplastic polymers, we also considered rear wipers and door handles, which are components made primarily of PBT and PET polyester polymer. Then, to handle the dismantling and stockpiling of the selected components, we hired Polini, a company in Brescia. Polini is a specialist in the dismantling of cars and a partner of FCA Stellantis, another group participating in the Car EService project. Airbags are dismantled using a device that detonates the explosive charge to release the gas inside the airbag. Next, the dismantler takes the airbag out of the vehicle and places it in a special container. The other components are taken apart manually and also placed in special containers. Then, the components removed from the vehicle become the material from which the post-consumer recyclate will be recovered. A total of 1,000 kg of airbags, 1,000 kg of wheel covers, and 50 kg of rear wipers and external door handles were collected.
The next stage is to sort the components according to the type of polymer. The composition is indicated on the part marking. Airbags are made of 100% of polyamide 6,6 fabric, but wheel cover can be either polyamide 6,6 or polypropylene. Both are reinforced with glass fiber and mineral fill. External door handles and rear wipers are usually made of glass fiber reinforced polyesters. The recycled components are cleaned of metal parts, then washed with pressurized water and greasing detergent, and finally dried. Grinding is the last pretreatment process needed to make the material ready for recovery.
Now, an industrial process enters the picture to manufacture the post-consumer recycled engineering polymers. The group can count on a production plant that is 100% dedicated to the production of sustainable, high-performance engineering polymers. Here, the circular economy concept has been implemented for years, and 100% renewable source energy is used to power production.
The material, ready for recovery, is stored in the raw material warehouse. From here, material samples are taken for quality control. Material characterization is performed to determine the type of polymer, its viscosity, the reinforcement material content, and the humidity. These characteristics are analyzed to select the optimal process condition to obtain secondary raw materials.
Based on the properties of the input material, a new material is formulated. This means our recipe is created with all the needed ingredients: the percentage of polymer, the type and percentage of reinforcement fill, and the additives. The objective is to obtain a product that meets the function and performance requirements. This formulation is done by the specialized engineer and technicians of the RadiciGroup Research and Development Department. Regarding the airbags, we have also determined the types and quantities of additives to be added to the base polymer, taking into account the presence of silicone on the airbag fabric. Silicone is not compatible with polyamide, and thus it is necessary to dilute the percentage of silicone by running a preliminary extrusion of the material.
The first stage of the production process is mixing. The polymer bases are loaded into silos and mixed with a mechanical system to homogenize the material. This ensures the quality and consistency of the chemical and the physical properties of the finished materials. The polymer mix is transported by pneumatic systems to the dosing units positioned above the extruder. According to the formulation, the dosing units feed the polymer, additives and reinforcing materials into the extruder, where they're all mixed together. In the extrusion process, the materials force through small holes to form threads or spaghetti. These are then cooled in water baths, dried, and cut into small cylinders called chips. Next, the chips are transferred into storage silos, where they remain until they are packed.
Our laboratories perform two main kinds of activities. Firstly, analysis of the finished product for quality approval and release of the product for sale. And secondly, characterization of the physical, chemical and mechanical properties of the material and the preparation of a technical sheet, which can be used to end-user developers. Testing is performed directly on chips or on standard specimens, which are prepared by injection molding. Tests carried out are testing for residual moisture content in granules, analysis of ash content to determine fill content, and characterization of mechanical properties, tensile, flexural and impact strength. For the EService project, we have equipped our laboratories with a new test instrument for fatigue characterization of materials. Fatigue testing is performed by subjecting the specimen to a variable load until failure occurs and taking into account the number of cycles.
After passing quality control, the materials produced are transferred to the packaging area. Packaging options are bags, octobins or tanks. Bag packaging is a fully automated process. The bags are hermetically sealed to prevent the escape of granules and to protect the material from moisture. The bags are then stacked on pallets and shrink-wrapped, ready for shipment.
RadiciGroup formulates, produces and characterizes the engineering polymers so that its customers can process them into products with specific functions and performance requirements. There are many different processing technologies, application sectors and intended uses. For the EService project, we consider two processing technologies. The first is injection molding, a classic technology for engineering polymers, which involves injecting the polymer melt under high pressure into steel molds that are held tightly closed by a press. The other technology is 3D printing, which offers almost total freedom in creating complex shapes without fixed costs for tooling, such as molds or the like. With the cooperation of some of our customers, a number of products were selected to test the processability and performance of the materials obtained from post-consumer recycling. The products manufactured for the EService project include both electrical device components and automotive parts for applications such as charging connectors for electric and hybrid vehicles, as well as mechanical components specifically developed to carry out validation tests. The processing of the material and the use conditions under which the end product will operate during its life cycle are aspects of a complex puzzle. To work well, everything must be carefully designed and rigorously checked. This will ensure that the delicate balance among the parameters is preserved. A useful tool for designers is CAE, Computer-Aided Engineering, or, in other words, numerical simulation assisted by software. CAE aims to virtually reproduce both the material molding process and the mechanical, thermal or other kind of solicitations that the part will be subjected to under use conditions. Everything possible is done to predict the behavior of the materials, right from the very early stages of product development. The goal is to identify and anticipate potential problems, select the material best suited to the application, and more generally, optimize the design. This process can also take into account eco-design and environmental performance. Material characterization is essential for accurate prediction, especially in the case of recycled polymers, which are subject to greater variability. Simulation allowed us to virtually reproduce the molding of various sample components and to carry out a subsequent validation, so as to confirm that the selected recycled material was indeed suitable for the application. We then gave the green light to further experimentation on physical prototypes.
Thanks to the European EService project in the automotive sector, we are able to work more in depth on recycling, circular economy and sustainability.
The EService project showed how teamwork among the various players in the supply chain is a winning strategy for a more sustainable future.
RadiciGroup's expertise in the formulation and production of engineering polymers made possible the evolution toward higher technical and environmental performance of recycled materials.
We are RadiciGroup. Let's team up for sustainability.